The North Link line runs from Suaoshin Station to Hualien Station and was originally constructed as a single-track railway as part of the 10 major construction projects in 1973. The railway spans 82.3 kilometers, featuring 16 tunnels with a combined length of 31 kilometers, 91 bridges, and 13 stations along the route. The entire line was officially opened on February 1, 1980. In 1992, the single-track railway was upgraded to a double-track system and electrified. The improved North Link line has a total length of 80 kilometers, with 13 tunnels spanning 34 kilometers and 10 newly constructed bridges. Along the route, there are 12 stations, including one newly built Wuda twin-track tunnel, replacing the original Wuda No. 1 and No. 2 single-track tunnels. Additionally, a new twin-track Guanyin tunnel, stretching 10,307.1 meters, replaces the original Guanyin, Guyin, and Gufeng single-track tunnels. The remaining tunnels have been either modified or newly constructed. The electrification of the North Link line was initially completed and opened to traffic in 2003. On February 1, 1980, after more than 6 years of effort by the Retzer Engineering Agency, the North Link line was officially opened to traffic. This led to the rapid development of tourism and natural resource industries in eastern Taiwan, resulting in a sharp increase in passenger and freight transportation demand. Although the railway had already implemented an automatic block signaling system, it remained a single-track line, using 37-kilogram steel rails and wooden sleepers. These limitations restricted both capacity and speed, making it difficult for passengers to secure tickets for eastern Taiwan routes. In addition, in 1990, the Council for Economic Planning and Development approved the long-term development plan for the cement industry, leading to the establishment of a specialized cement industrial zone in Hualien. This further intensified the demand for both passenger and freight transportation on the North Link line. To address transportation issues in eastern Taiwan, the North Link line underwent a series of major upgrades starting in 1992, following directives from the Executive Yuan. These improvements included double tracking, heavy rail reinforcement, electrification, and the computerization of signaling systems, all aimed at increasing passenger and freight capacity. Whenever possible, the original tunnels from the 10 major construction projects were preserved and refurbished as single-track electrified tunnels. Additionally, a nearly parallel single-track electrified tunnel was constructed on the westward side. However, due to the mountainous terrain along the North Link line, new sections of track had to be built in many areas to complete the double tracking and electrification. During the construction of new lines, the limited space along the existing railway posed significant challenges. Many of the new tracks were built close to the original route, leaving very little room for construction. Moreover, since train operations had to continue throughout the project, carrying out improvements was particularly difficult. After more than a decade of work, most of the construction was completed by June 2003. The electrification opening ceremony was held in Hualien on July 4, 2003, with then-President Chen Shui-bian presiding over the ribbon-cutting ceremony. Delays caused by water seepage issues in the new Yongchun Tunnel and track improvement work in the Nanao Tunnel were finally resolved in January 2005, marking the full completion of the double tracking and electrification project. After completion, the North Link line saw a significant increase in train frequency and a substantial reduction in travel time between Taipei and Hualien. The North Link line spans a total length of 80 kilometers, with tunnels accounting for 34 kilometers of the route. There are 13 tunnels along the railway. Among them, there are 9 single-track tunnels and 4 double-track tunnels. Most of the new tunnels were constructed along the western track, while the original tunnels were designated as the eastern track. However, due to geological considerations, the new Heping Tunnel was the only newly constructed tunnel on the eastern track. During the railway electrification project, tunnel excavation was the most challenging task. In particular, the Yongchun Tunnel, located near a water-bearing zone, and the New Guanyin Tunnel, which stretches over 10 kilometers, posed significant construction difficulties. As the North Link Line was upgraded from a single-track to a double-track system, extensive tunnel modifications were required. Since the original tunnels were only capable of accommodating single-track trains, new tunnels had to be constructed regardless of whether the old tunnels were retained or abandoned. If the original tunnels were preserved, only a new single-track tunnel needed to be built. If the original tunnels were abandoned, a new double-track tunnel had to be constructed to accommodate train operations. The term single-track tunnel refers to a newly constructed single-track tunnel serving as the westbound track, while the original tunnel built during the 10 major construction projects was retained and modified to serve as the eastbound track. The term double-track tunnel refers to a newly constructed double-track tunnel accommodating both eastbound and westbound tracks, while the original tunnels built during the 10 major construction projects were either abandoned or repurposed for other uses. The single-track tunnels along the North Link Line include New Swao Tunnels number 1 to number 4, New Yongchun Tunnel, New Nano Tunnel, New Herin Tunnel, New Qingshui Tunnel, and New Chongda Tunnel, with a combined length of 18,681.2 meters. The double-track tunnels include New Dongnao Tunnel, New Wuda Tunnel, New Guanyin Tunnel, and New Heping Tunnel, with a combined length of 15,209.5 meters. During the railway electrification project, tunnel excavation was the most challenging task. In particular, the Yongchun Tunnel, located near a water-bearing zone, posed a significant challenge in terms of construction techniques. The construction method for the southern entrance of the new Yongchun Tunnel adopted a combination of drainage tunnel dewatering and hot asphalt grouting for water blocking. First, a large diameter drainage pipe was drilled to reduce water pressure from 20 meters outside the tunnel. This was coordinated with drainage tunnel dewatering, supplemented by hot asphalt grouting within approximately 15 meters near the tunnel to effectively block groundwater and provide the basic conditions for excavation. The excavation process followed the principles of distant drainage and near grouting: support first, then excavate, and reinforce simultaneously. With the implementation of these measures, the project was successfully completed. The hot asphalt grouting method is the most effective solution for tunnel construction encountering massive water inflows. The new Yongchun Tunnel is a highly successful example of this technique. The New Guanyin Tunnel, exceeding 10 kilometers in length, is situated in an area with weak geological conditions. To prevent collapses, the construction adopted horizontal pipe roofing and vertical ground reinforcement methods. The horizontal pipe roofing technique involves using a cluster of steel pipes as protective material for the excavation face and as horizontal support for the tunnel arch. This method follows the principle of protection first, excavation later. The vertical ground reinforcement method involves drilling a system of boreholes from the ground surface above the tunnel before excavation. Steel pipes are embedded within these boreholes and filled with cement grout. These steel pipes, of varying lengths, serve as reinforcement materials to improve the rock foundation, preventing potential collapses or landslides near the tunnel entrance during excavation. The North Link Line passes through various overpasses and river bridges of different sizes. Among them, 22 newly constructed bridges feature reinforced concrete permanent structures. Most large bridges utilize pre-stressed concrete beams with spans ranging from 20 to 40 meters. The single-track bridges along the North Link Line include New Xinghu River Bridge, New No. 6 Overpass, Wuyun River Bridge, New No. 7 Overpass, New No. 8 Overpass, Nanao Bridge, New Daiqingshui River Bridge, New Shaoqingshui River Bridge, New Sanjian River Bridge, and Beipu River Bridge. The double-track bridges along the North Link Line include New No. 3 Road Bridge, New Baimi River Bridge, New Dongnao North River Bridge, New Dongnao South River Bridge, New Nanao North River Bridge, New Nanao South River Bridge, Gufeng North River Bridge, New Heping River Bridge, New Herin River Bridge, New Liwu River Bridge, New Meiluan River Bridge, and Fengsuan Bridge. Located between Suaoxin Station and Yongla Station, New Baimi River Bridge is Taiwan's first railroad co-constructed bridge, with the railway on the upper level and the highway on the lower level. New Heping River Bridge is the longest bridge on the North Link Line. Due to geological considerations, it is the only newly constructed bridge along the line positioned on the eastern side near the Pacific Ocean. The surrounding area includes Heping Power Plant and Taiwan Cement's largest industrial park. Track engineering includes subgrade, ballast, sleepers, rails, signage, and related auxiliary equipment. Most of the subgrade engineering along the North Link Line closely follows the mountain slopes. Due to the rapidly changing terrain and steep mountains, deep excavation and high embankments are required, resulting in a significant volume of earth and rock fill. The construction primarily relies on mechanical methods. In mountainous areas, excavated material from tunnels is reused as subgrade fill, while in plains, sand and gravel are sourced from nearby rivers. Ballast replacement can be carried out using fully mechanized, manual, or mixed methods. Strict quality control is required for the ballast material, including its composition, particle size, and soil content. Before electrification, the North Link Line used wooden sleepers. During the electrification process, wooden sleepers were replaced with stronger concrete sleepers. The installation of concrete sleepers requires steel shoulders and spring fasteners. Initially, these components were imported, but after successful domestic production, local materials were used, reducing costs to 1/3 of the original. The rail upgrading process on the North Link Line involved replacing 37 kg rails with 50 kg heavy rails. There are two methods of rail replacement: replacing fixed-length rails and replacing long rails. The tools used for fixed-length rail replacement are similar to those used for sleeper and ballast replacement. Long rail replacement requires aluminothermic welding, and it is crucial to record the ambient temperature during installation, as extreme temperatures can cause rail fractures or deformations. The ballastless vibration damping track system, introduced from Japan, is a modern track system. The North Link Line utilizes this system in tunnels spanning approximately 52 kilometers between Nanao Station and Cheongda Station. These tunnels include New Wuda Tunnel, New Guanyin Tunnel, New Heping Tunnel, New and Old Hurin Tunnels, New and Old Qingshui Tunnels, and New and Old Cheongda Tunnels. Along the North Link Line, substations are installed to convert the electricity supplied by the power company into the voltage required for railway electrification. This power is then supplied to the newly installed overhead catenary system. Electrification includes transmission lines, substations, catenary wires, power distribution switching operations, remote control, and electric locomotive traction. Each Taiwan Railways substation is connected to Taipower substations via two high-voltage transmission circuits, delivering a three-phase high-voltage AC supply. Except for the Heping substation, which operates at 161,000 volts, all others operate at 69,000 volts. There are three substations along the North Link Line, located at Suaoxin Station, Heping Station, and Hualien Station, with an average distance of 40 kilometers between them. Neutral zones are set up in between as feeder insulation areas. Each substation transmits power of different phases northward and southward, with the neutral zone positioned 20 kilometers from the adjacent substations. The catenary system is a key component of railway electrification. It consists of feeder circuits, overhead contact wires, warning signs, and protective equipment, forming a complete electrification system. Generally, movable cantilever or bracket steel structures are used for support. However, in single-track tunnels along the North Link Line, a rigid conductor rail contact system is adopted. Supervisory control and data acquisition system centralizes the management of Taiwan Railways electrified lines at the Power Dispatch Center in the Taipei Integrated Dispatch Center. The control panels display the switching controls and status of substations, neutral zones, catenary systems, and remote telemetry meters. Electric locomotives use pantographs to draw 25,000 volt power from the catenary. This electricity passes through transformers and rectifiers to drive DC motors, generating traction power. The current then returns to the substation via the wheels and steel rails, completing the circuit. The telecommunication engineering project includes upgrading the existing telecommunication cables to high-shielding cables, installing fiber optic cables and ground lines, and updating related communication and lighting equipment in tunnels, station yards, and office buildings as part of new construction and renovation efforts. Railway signaling is the primary system for guiding train operations, akin to the human nervous system coordinating body movements. The centralized traffic control system integrates remote control technology with railway operations. After the electrification of the North Link Line, the signaling system was upgraded to a computerized central control system, eliminating outdated manual signaling stations such as the Guanyin Signal Station. Suaoshin Station is located alongside Provincial Highway 9 in Suao Township and serves as the starting station of the North Link Line. It is the closest station to Wulakeng Scenic Area. The Suaoshin Tunnel Group, situated between Suaoshin Station and Yongla Station, consists of two single-track tunnels. The new tunnel is on the west track, while the old tunnel is on the east track. Yongla Station is classified as a third-class station, with only local trains stopping. Passenger traffic is low, and the station primarily serves freight transport. It functions as the cement freight hub for Taiwan Cement and is the main gateway for the Suao plant of Taiwan Cement. The station features a spacious yard with multiple sidings to accommodate freight trains, where bulk cement wagons are frequently seen. Located between Yongla Station and Dongao Station, the New Yongchun and New Dongao Tunnel Group includes the New Yongchun Tunnel, which consists of two single-track tunnels with the new tunnel on the west track and the old tunnel on the east track. The New Dongao Tunnel is a double-track tunnel containing two rail lines. Dongao Station features two island platforms and serves both passenger and freight transport. It is also the freight hub for Xingfu Cement, with bulk cement freight trains commonly seen at the station. Although the station is built at ground level, the platform area is actually situated on an embankment structure, with part of the platform extending over Provincial Highway 9. Due to its freight function, the station occupies a vast area with multiple sidings primarily for freight operations. Located between Dongao Station and Nanao Station, the new Nanao Tunnel consists of two single-track tunnels, with the new tunnel on the west track and the old tunnel on the east track. Nanao Station is located closer to the main settlement of Nanao Township and serves as the primary transportation hub of the area. The new Wuda Tunnel, located between Nanao Station and Wuda Station, is a double-track tunnel with two rail lines. Wuda Station is a Type B simple station managed by Nanao Station, with only local trains stopping. Originally, the station had two side platforms, which were later replaced with two island platforms. The distance between Wuda Station and Hanben Station is 13.2 kilometers, making it the longest station-to-station gap on the North Link Line. The old Guanyin, Guin, and Gufeng tunnels, located between Wuda Station and Hanben Station, were replaced by the new Guanyin Tunnel after the electrification of the North Link Line. The new Guanyin Tunnel, over 10 kilometers in length, is a double-track tunnel with two rail lines. Hanben Station is a third-class station with only local train services. The original Atayal name of Hanben is Blaihin, meaning gateway. Located between Hanben Station and Heping Station, the new Heping Tunnel is a double-track tunnel with two rail lines. Heping Station is located in Heping Village, Shilin Township, Hualien County. It is a settlement of the Truku people and serves as an important base for Taiwan Cement, where cement is produced. The station is adjacent to Heping Industrial Zone, which includes Taiwan Cement's Heping Plant, Heping Thermal Power Plant, cement storage facilities, and a dedicated industrial pier. Herin Station is located in Xiaolin Township, Hualien County. In terms of freight tonnage and revenue, it ranks as the second-largest freight station in Taiwan. Located between Herin Station and Chengda Station, the new Herin, New Qingshui, and New Cheongda Tunnel Group consists of 3 sets of 2 single-track tunnels. The New Hurin Tunnel is on the west track, with the old tunnel on the east track. The New Qingshui Tunnel is on the west track, with the old tunnel on the east track. The New Cheongda Tunnel is on the west track, with the old tunnel on the east track. Cheongda Station is near the famous Qingshui Cliffs. Between the 1980s and 1990s, the station was featured on the cover of junior high school social studies textbooks. Xinqing Station is located in Xinqing Township, Hualien County. It serves as the freight hub for Asia Cement, with approximately 7,700 metric tons of bulk cement transported daily from the station. Suaoxin Station is 3 kilometers from Taroko National Park and 17 kilometers from downtown Hualien. Jingmei Station is a Type B simple station without ticketing staff, with only local trains stopping. It is managed by Xinqing Station. Beipu Station has a single platform and primarily handles freight transportation for the cement industry along the route. Hualien Station was originally established during the Japanese colonial period under the name Hualien Port Station, located at what is now the Hualien Railway Culture Park. After World War II, the station was renamed Hualien Station, and the old station was officially decommissioned in 1982. The current Hualien Station began operations at its present location in 1979. The electrification of the North Link Line holds great significance for the development of Taiwan's eastern region. However, this 80-kilometer railway winds through rugged mountains, requiring the excavation of 34 kilometers of tunnel to achieve full connectivity. In addition to overcoming geographical obstacles, ensuring uninterrupted train operations was a formidable challenge, akin to altering clothing while wearing it. For construction personnel, this was a true test of technical expertise. For more than a decade, engineers and workers struggled through overgrown wilderness and deep, dark tunnels, battling the forces of nature to accomplish what once seemed an impossible task. Today, as we enjoy the convenience of improved transportation in eastern Taiwan, we must be grateful for the selfless dedication and sacrifices of those who made it possible.